In this second part of the MCP tutorial, we will continue our MCP implementation for the browser and Docs API and the terminal. So to continue with the fourth demo for the Playwright MCP, I prepared here the demo script, like all the other scripts with the crew agent and task. But before going to the crew agent and task specification, we will look here into some configuration that I added. So first we need to define the MBX command for our Playwright MCP, and I'm defining here the tools that we want to use for my demo, and it will be only the browse navigation. So the main purpose here is browsing or navigating to a specific URL and try to summarize the result. In other words, I'm trying to consume the playwright using the MCP way. So it will be consumed from the LLM model or from our agent actually by calling the tool that will consume the MCP server. The playwright will have some kind of environment variables that could be customized. So what I'm doing here, that I'm trying to get everything starts with the Playwright MCP and getting it from our environment and then trying to inject it or setting it. This we will use it here in the MCP server to inject it as environment variable that is related to the Playwright MCP. So here again, so the URL that we are using will be the playwright.dev URL and get some content from there. The MCP server stdio will have our mbx command that will call the MCP from the Playwright. The default environment that we have, like we did in the other demos, we also filter here the tool and restrict it only to the single tool that we need to use in this demo, which is a browse navigation. The agent will be simple. From the backstory here, we are trying to instruct the agent that there will be an exact tool name, and also it should be expected an action as a JSON object, and also the output will be in the shape of a markdown with a title and some kind of optional notes. We are supplying here Playwright MCP for it and our local Ollama LLM. For the task, it will consist of two steps. That first we need to call the browser. So we need to call the browse navigation tool. After getting page content, we need to have some kind of summary from the page to just validate that we already fetched that page. For example, we need to get the title and maybe note about the page to verify that we call the MCP and we get the result actually out of the MCP server. And here the expected output, like always, is just acting as a validation for the CrewAI. It can validate that it gets the answer and could stop the React loops. So here the final answer should consist of the title and maybe note and summary. And here we need to initialize our crew and kick it off. So I will run the example. It will be poetry. So here we can see the result already. We already see here that there is a title is being extracted from the web page. So fast and reliable end-to-end testing for modern web apps. And this is the Playwright. We have also here some kind of notes and also the tool that is being called from the MCP server. If we go back a little bit, we can see tool output actually. We can see that there is a snapshot being saved in the temporary file for the page itself. And we can see the MCP tool is being already connected and then being called with a specific URL. For the next example, so the demo number 5, we are trying here to consume the context 7 documentation service through the MCP server HTTP this time. So we used to use the MCP server stdio. So this time we will use the MCP server HTTP, and we will see how we can inject the API keys, consume the MCP over the HTTP. Just as a summary, the context 7 is a documentation service that exposes library docs through MCP. So tools like Resolve Library ID and Query Docs return up-to-date snippets from real project. For example, in this demo, we will navigate to the FastAPI docs and we will try to instruct the context 7 to bring us example of some use cases using the FastAPI. So in the beginning, we need to make sure that we get the context API key. Here I set it already in my environment and I'm getting it. The script will fail if the key is not being supplied because the MCP server will not be able to initialized. So here we supply for the MCP server HTTP the URL for our MCP, and we supply the context API key. For the next two variables, we will define the targeted documentation and our topic. In our case here, we are looking into the FastAPI docs. So this will be the library that we are targeting with our context 7 query. And the topic is more about the query itself. So what we need, or the minimal prompt that we need our agent to process. So here in the topic, we are asking to build a minimal ASGI app with a lifespan event handler. And like always, for our CrewAI, we will have an agent and task, a single agent. So this agent is being instructed here, or the backstory for the agent, also again restricting or making sure the agent will do the React loop strictly with the action that should be a tool name out of our tool list, and the input which will be a JSON object, and also some other specific instruction what to expect from the preferred library ID. Here I try to hard code some of the instruction in order just to get a concurrent answer, since I'm using a local LLM. But normally you shouldn't have this kind of restricted instruction inside the backstory itself. For the task, we will have 2 or 3 steps. So we need to resolve the library ID from the context 7. So we will call the library name through the MCP server, and then we need to resolve what the actual library ID through the context 7. And once we get it, we need to ask for the documentation using the query docs tool, and the final answer will be the markdown of what we asked for. So we asked for an example, Python example. So the final answer should be a markdown with a Python block from the docs regarding our request. And here, like always, we have the expected output that will make the agent validate the answer before continuing or stopping the React. And here we are just kicking off the group. So I will run the example. So here we have the final result, and we can already see from the final result that what we ask for is a Python example. The markdown is already being implemented, which includes the lifespan function and the initialization of the FastAPI with the lifespan. If we go back a little bit in the history, we can already see the tool called and tool initialization through the MCP. So here's the tool output, and here we can see the MCP connection to the context 7, and the tool execution completed with all the result and the examples, and also defining the source of our docs from the FastAPI. In the last example, we will discuss about the terminal sandbox. So in this repo, the terminal sandbox is a teaching name for a very small controlled MCP server. So we are implementing actually a mini MCP server, which runs in a separate process over the stdio, the same wiring as the real MCP demos that we did so far. But instead of opening a full shell, it only exposes the save, read-only tools. The agent's word is limited to a single directory you choose via Sandbox CWD, which in our case is related to the workspace root that we initialized in the config, and it will be the demo MCP workspace. If we look into the Sandbox shell server, which will be the MCP server in our case, we can see that we are exposing a single tool here. With a decorator for the MCP tool, we are exposing the list workspace tool to the MCP server. And this tool actually just doing a simple thing by trying to navigate or list all the directories and files exist in the requested directory or the sandbox directory. And here just a small guardrails. If there is no limit for the max entry, we're just setting it to 50. Otherwise, we just get the max between 1 and the max entries. And also if the sandbox directory is not actually a directory, so here we just need to return a message saying that the sandbox is not a directory. The first line in the result will be the root directory, and then after getting all the names and sorting it, we need to add it to the lines result, and the final line will be a summary of the count of how many files that we found in this directory. In the main function here, we are initializing our MCP by running the by running the MCP through the stdio, so it will be consumed by the CrewAI agent through the stdio. Going back to the example or the demo, we can see here that the shell MCP is initializing the MCP server stdio. So the MCP server stdio will run the command from the system executable. So it's the same Python as our demos, and the args will be the Python script that we have it here. So it's actually executing Python for our Python script, which will run in a different process. For the CrewAI setup, again, we have one agent and one task. So the Sandbox Explorer is the agent that will do the listing. And here we have some instruction or a backstory for our agent, like always, to make sure that the agent will understand that we will have this tool, which called the list workspace, and the final answer will be a markdown summary of how many entries and the entries names. Also, the task here will be two steps. So first we need to call the list workspace, and then the answer should be in a sort of markdown result, having all the entry count and the directories or the file names exist in that sandbox directory. Then we will have the final wiring up through the crew model and starting it. So I will run the example. So here from the result, we can see from the last tool output, we can see here the exact output from our Sandbox tool and the MCP server tool that we already implemented. So here we see the summary and we see the files in our Sandbox directory. And we can verify actually if this is the exact files exist in that directory by navigating to this directory very quickly. So if we navigate it there and we try to list whatever exists in that directory, so we actually see that we have 3 files in that directory, and this what already been summarized here at the markdown. So after having these 6 demos in the part 1 and part 2, here's the takeaway. Without MCP, your tool integration are scattered across your application code. With MCP, all your tool surfaces live at the server boundary. Schemas, authentication, network policy, observability, that's actually a good thing. You know exactly where to look and everything seems like organized. So more or less the full equation for a safe agentic system is a model, the LLM model, the tools, the orchestration, and the guardrails. You cannot skip any of these. A good model with bad tools is dangerous. Good tools with no guardrails are dangerous also. Good guardrails with a bad model are unreliable. So all 4 have to be in place. Thanks for watching. If you want more of this, like the video, subscribe with the notification on, and share it with your friends. We release new videos every week on AI development, agents, and developer tooling. Thanks for being here.